Hi, this video covers how to convert Eagle files into KiCad format. It's generally straightforward, but there are a few subtle points that this video will hopefully cover. First, we need to go to File, Import Non-KiCad Project, and select Eagle Project. Select your folder, the folder with the board and schematic files, and then just click the schematic and open that. That will open both anyway. Then prompt you for the destination folder. Pick an empty folder. I'm going to store it here. Okay, the schematic is imported, but for the PCB, layers need to be mapped. You can see the Eagle layer names on the left-hand side here. Most of the mapping can occur automatically, so you can select Auto Match Layers here. It will map most of the layers, but there might still be some that need mapping manually. And if you click on OK, then you'll only find out later on in the workflow, so you'll have to go back and restart. So it's an iterative process. And I happen to know that the milling layer is used on this PCB, so I need to map that. So I'll pick the milling layer and pick the edge.cuts layer and manually move that across. So you can see it there, milling edge.cuts. I know that the other layers are not being used, so I can click on OK. Alright, the PCB is imported, and if I click on B, it will fill in the zones. And you can see there's some problem here. The ground connection needs to be made here. Perhaps there was not enough space for thermal relief here. And there will be other problems as well. We can start sorting them out later, but one thing needs to be immediately addressed. And that is, if I click on this button here to update the PCB with the schematic changes, all of these component positions are going to move, and I don't know what the reason for that is. That needs to be fixed, and I don't know what the solution to that is other than what I'm about to propose here. And that is to first save the file, and then go to Tools, Scripting Console, because I'm going to try to save the positions of all of the components so that when they move off the correct locations, I can move them back onto the right place. So to do that, I'm going to use a Python script, which I've already written. I'm just going to show you the commands which I'm going to use. What these do is, the first two just specify a path where my script is stored. And then I import the script. My script is called ktools.py. And then I'm going to call this function list coordinates. And what that's going to do is just dump out all of the coordinates of every component into a Python format, which I can then reapply later. If you're interested, this is what the code looks like. There's not much to it. There's only one main function. What this function does is it gets a board object, and then it gets all of the footprints into a list. And then it iterates throughout that list. And as it iterates, it gets the position and the orientation of all of the components, and then it prints it out in a Python format. Okay, back to the Python shell. I can type in those commands, import sys, and then paste the next one. That's setting the path. And now I import the functions within the Python file. And now if I type list coordinates like that, what it's done is, if we ignore the holes, you can see the other components. So for example, for R1, the component value is 1K, and the coordinates in millimeters are listed there as well. And it's been rotated 180 degrees. Similarly for all the other components. So that's useful, but what I can do is also call that function with format equals Python. And hit enter. It's dumped out the same information, but now in a Python format. And I'm going to copy this. Just grab all of that to here. Copy that. I'm going to bring up my Visual Code. New file. And give it a name. myfix.py. And just save it to the same Python folder as before. Paste in. There it is. Okay, everything is here, so you can see what it's doing. It searches for every one of those references, and then it moves them to the correct position. So if we look at R1, it finds it, and if it finds it, then it moves it to those position values in millimeters times 1 million. That's the resolution that KiCad needs. I'm going to save that. Okay, so that's done. I can minimize that for now. And now I'm going to update the PCB. And you'll see what happens. This is the problem which I was talking about. All the components have moved. So I'm just going to dump them to the side for now. Fortunately, it's now easy to move them back to the right place using the Python script. Bring up the Python console again. I can now just type import myfix. And now I can call the function myfix.moveItems. If I minimize that, you can see everything's now back where it should be. Hit escape. Now. And everything's exactly where it should be. And I can save that. And now if I ever have to update the PCB again from the schematic, that'll be no problem. As you can see here, there's no issue now. Okay, so that's done. Now, there will be errors, and you can run the design rule checks to see them. But one problem I found is if you have filled zones, then one property needs to be changed from there. So I'm going to double click on this, and you'll see here, this is strange. I don't know why it's up. I'm going to set it to 0.3, which is a bit more realistic, and press B again. Okay, I'm going to run the design check now, see what else is remaining. Run DRC. And I'm only going to look at the errors for now, not the warnings. I can address the warnings later. I have 20 errors, and normally what you can do is just zoom in and then click on any of the errors, and then you'll see the focus moves to where the problem is. Here it's complaining about items that are not allowed in a keep out area. I'm just going to move that off the screen. And the reason for this is there's a crystal oscillator here, and sometimes you might not want a filled area underneath it, just to reduce the capacitance. I don't think it's very essential for this particular board, but nevertheless, I'm going to try to fix this. What I'm going to do is zoom in and double click that. You can see that by default, all of the rules are enabled, and this is not correct. I'm going to undo those and click on OK. Hit B. Okay, that's one of the problems. Here's another problem. The issue here is there's a clearance violation, and it looks like the reason is because that's the board edge here. There's no real problem here except that this pad is beyond the board edge, and it was intentional. It was in the Eagle file, because with Eagle you don't really have a good method of doing shaped pads, but we should try and clean this up. The easiest way to fix this is going to be to change the footprint. So I'm going to select the footprint, right click, and open in footprint editor. And you can see it looks a bit weird here with these polygons, but that's just the way the shaped pad was made in Eagle. It's not needed with KiCad. I want a shaped pad, but I want to obviously chop off that corner here. With KiCad, the shaped pad is much easier. You just select the pad and then press Ctrl E. And now you're in the pad edit mode. I'm going to select graphic polygon, and I'm just going to roughly place that polygon where it should be. I'm not going to be accurate here. Just like that. And hit Ctrl E again. That's done. And now quickly do the same thing with the other one. So select that, press Ctrl E, graphic polygon, and just sketch it out again. Again, no need to be accurate at this stage. And then hit Ctrl E again. So that's approximately right. I'm going to now select a finer grid. 0.1 millimeters is good. And zoom in a lot on this. Select it, Ctrl E. Now I can move this across up and down until it's aligned exactly where it should be. It's very hard to see, but you just see in the background just about the, what's wrong? Select that again. and just move it to fit with the old polygon in the background. This quick thing, just repeat all the way around, that's it. That's looking much better. And I'm not really sure how much of a corner I need to remove, so I'm just going to experiment here. This is about right. And it's quite easy to fix later on anyway. That'll do. Hit Control E, and then repeat with the other one as well. So Control E again, zoom in, position that. There. And again, just slide this a little bit. Just eyeballing this. Control E. Okay. And then Control S to save that. And then if I just quickly look in the PCB editor, that is looking better. And I'm going to run the design rule check again. Oh, same amount of errors. What's going on there? Ah, my fault. The polygons are still there. I forgot to remove those polygons. So just select them and delete them off. Okay, save that footprint. And rerun the DRC. Great. So that's 6 errors gone. And you can keep repeating this to try and solve all the other ones. Here's another one. There's a problem with either the footprint or the copper fill. And again, it's an Eagle related problem where a shaped pad was required and it's causing some issues with KiCad. The real problem here is this is a footprint for an LCD, and this is just not a good way of doing things. These pads are supposed to be used for the LCD backlight, and they've got like a rectangular slot in there. So really this footprint needs to be changed because polygons have been used here and you don't need to do that with KiCad. So again, open that up in the footprint editor. And you can see here the issue. There's an edge cut there. If I select that, you can see it more clearly. So you can see how these footprints were created, and this is not needed, so we can edit the pads. It was created as an SMD pad, but then with a slot cut in it. That can be replaced with a through-hole pad. I'm going to change that SMD pad to through-hole. And the pad shape is rectangular. The hole shape can be oval. Okay. I'm going to guess and put this at 1.2. And for the Y value, it's got to be less than 4.4. I'm going to put 3. Click OK. Okay. That's not bad actually. I could keep that. It's a good guess, but I'm going to make it just slightly smaller so that it's closer to this edge cuts layer. So yeah, just through trial and error, I'm going to modify that again a little bit. I could do it more accurately by looking at the datasheet, but it's a simple LCD display. It's not critical. Okay, reduce that to 1.15 and maybe 2.9. Yeah, that's 3 before. I'll change it to 2.9. Click on OK. Getting closer, but can reduce it a little bit more. One more try. This time I'll try 1.05 and 2.8. Oh, that's perfect. That's done. Let's do the other one too. Now we know the values. This is going to be quick. Okay, through hole as before, oval, and it was 1.05 and it was 2.8. Great. And these other layers can be deleted now. The polygons can all go. That's all Eagle historical stuff. And the edge.cuts layer as well can also go. And do the same thing here. Delete all of those polygons. Okay, no more polygons there. And we need to get rid of these edge.cuts lines as well. Just manually delete those. Great. Control S to save that. And go back to here and rerun the DRC. Excellent. Now just one error. Oh, that's the unconnected item, that connection. And that's this ground connection here. These pads are very close together. I think they're 1.27 millimeters spaced. And one way to fix this would be to change the thermal relief settings. I think it might just be easier to just remove the thermal relief off that pad. I'm just going to select that, right click on properties. Go to clearance overrides and change that pad connection value to solid. Let's see if this fixes it. Hit B, and that's filled. That solved it. There's no more errors, but there are warnings, and those are going to be silkscreen related mostly. Oh, there are actually some track related warnings as well. Let's try to fix those. I'm just going to click here. Yeah, there's a short track there. Just delete that. I think there's another one here. Yeah, there it is. Hit delete on that as well. And then run the DRC. There's still one more, I think. Yeah, I'll just show you the other way of doing this. Go to Tools and clean up tracks. And then just click Build Changes. And then update PCB. Hopefully that's got rid of those warnings. Great. Yeah, so those track related ones have gone, and now these are mainly all silkscreen related. There's a couple warning about the footprint not matching the library main. Main is just the name of the file that I've got here. These are the footprints that got edited, and if you wanted to, what you could do is open up the footprint editor for those components and do save as and save them off to a different library, but I'm not going to bother with that for now. I'm just going to double check what that looks like in the 3D viewer. It looks fine. You can see here the changes that we made on the switch. And also the slots look about right for the LCD. Okay, I'm going to close that. One more thing that's worth mentioning is if we have a look at the schematic, there's a couple of issues here that need to be addressed. One issue you'll see when you try and add a new component. So I'm just going to hit A and then select any random component, just a resistor. Now you can see that the font is of a different size for the new component that got added. It's larger on the eagle symbol than the one that was in the KiCad library. And it just looks ugly. So you do want to correct that. And the easiest way to do that is just to memorize which component you added, the name of it, so that's R9. And then I'm going to bring up this file in Visual Code, the schematic file. Open that up. Go to the KiCad project folder. And the _SCH file is the one that we want. I'm just going to close the old schematic. And now I'm going to search for that component that got added, the R9. There it is. And you can see that the size is 1.27 space 1.27. But if I search for any other component, for example R1, the size is different. So I'm going to copy this and then go back to the top of the file, Control F, expand that, and then search and replace with these values, 1.27 space 1.27, and then replace all. Excellent, that's done. And then save that. And I'm going to reopen that schematic. Perfect. Now they match. I can remove this new component now and just save that. And there's one more issue as well, which needs to be addressed on the schematic. And that is, if you try and click anywhere on the schematic, the outer frame that's been drawn in the schematic keeps getting selected as well. And I don't know of a good solution there other than to simply delete that frame. It's not essential. The title block can remain where it is. And that's it. I think everything's done now. I'm going to go back and edit the PCB and tidy up the silk screen, but electrically everything should function now. Please see the links for the Python file which I used. Thanks for watching.